Thank you. Thanks for the intro. All right. Thanks for coming. Thanks for showing up. I really didn't think there would be so many people today, so it's very cool. As a starter, I just want to say, who this talk is for, so that you have your choice to stay or to leave. Fine by me. So this talk is for programmers and game designers that want to, get started with multiplayer games. In particular, I'm going to take a look at the Coherence tech stack, which is the company I work for. But some tips will be good for any technology, I guess. If you don't identify with this description, then in the other room, if you're an artist and you're here by mistake, Inna is giving a very interesting talk on colors. And if you want to leave the room, no offense. 3, 2, 1. I won't remember your face. No, I'm joking. Okay, so who am I? And why am I presenting myself, actually? I never really used to introduce myself when I was working at Unity before. The point that why I'm introducing myself here is because there is a little bit of history with multiplayer and me. So, my name is Ciro Continisio, and I currently work as a game developer for samples and quality at Coherence, which is this company that makes this technology for making multiplayer games. Previously, I was a creator advocate and a game developer at Unity, where I worked on this stuff here, Gigaia, if you have heard of it, the open source project Open Projects, and the game Chop Chop. I also made the Unity Playground, which was a tool for teaching game dev to kids. And then, before that, I was a certification tester and a developer a long time ago with my company called Tiny Colossus, and I made these 2 games. And these 2 games actually have a very peculiar thing that joins them. It was a puzzle game for mobile devices and PC, and then we made, with a friend of mine, a local co-op shooter. And the red thread that connects them is that I chickened out of making them online multiplayer. And that decision was maybe something that made these 2 games. These 2 games were not very commercially successful, I have to say. And one of the aspects was maybe that they could have benefited from having a multiplayer aspect, especially the second one. So yeah, at the time I thought it was an endeavor too big for me. I have to be honest, not to excuse myself, but Unity and multiplayer were really not like playing well together. And it was other times. Making multiplayer games was much harder. So when I left Unity last year, I got approached by a person that said, "Do you want to join us? We're making a multiplayer thing." And I was like, multiplayer, Jesus. Okay, like this is a challenge, like I want to learn about this thing that I got scared so much of during the years. Who here is making multiplayer games? Okay, a few hands. Who here would like to make multiplayer games, but is a bit worried about them? Okay, so you're in the right place. We bond. So this is a new adventure for me. Again, I'm a bit new to this world, but I think there's some interesting stuff in this technology that I'm going to show you that really breaks that barrier a little bit more than what it was in the past. And like my friend Shia LaBeouf likes to say, why leave it as a dream to make a multiplayer game? So my hope is that he will inspire you, me and him will inspire you to maybe make a multiplayer game this weekend, a Nordic Game Jam, who knows? So yes, yesterday you said tomorrow, so just do it. So where do you start from when you're thinking like, I want to make a multiplayer game, and maybe you will pick up this technology for this this weekend. And by the way, I just want to say, I'm going to do a little bit of slides, and then I'm going to do an actual demo on the product so you see how it works. So stick with me for a second. So, the thought process, right? Like you want to make a multiplayer game, where do you start from? And usually the first question that one asks themselves is about topology, network topology, right? So how are the different actors on this game, on this network, how are they distributed? And there are several topologies. And there's a lot of terminology bouncing around. I'm sure you're familiar with most of it, but just to, as a quick recap, we have the typical one where we talk about client-server, or server-authoritative sometimes it's called. And sorry, one small thing. I chose a lot of games as images I'm not necessarily 100% sure how they are organized, their tech, because some of the tech here is also like proprietary and stuff. I'm just using them as an example. So if, it's just, I don't know if Apex Legends is like organized exactly as I'm saying, but just using them as an example of genre. So in this case, for example, client server is a typical architecture where used in shooters, in first-person shooters, third-person shooters, where you have a server that controls the game, and clients just connect to it, and they send their inputs. You have, so the network, let's say, looks a little bit like this, right? Like the clients, there's different clients. For example, in Splatoon, there's matches of 4, and then they all connect to a server that orchestrates the game. This is also the case, of course, for MMOs, where the server is running the actual world of the game, and then many clients connect to it. But the server has kind of like the final word on what's happening in the network simulation. You have topologies like, well, I call it peer-to-peer. So basically, the idea here is servers, obviously, as you probably know, bring in costs. Like when you're structuring your game to have a server, you're talking about a huge actual cost to run the game, which also, how do you say, waterfalls on how you monetize the game, because now you need to give that cost to someone, and maybe you need to give it to your players. That's why people make like games with seasons, with passes, with battle passes, because you need to recoup that cost somehow. So sometimes you can do without a server. That's not always the case, but for games like these, in which basically, as you're playing with other people, the chances of people cheating to each other are way lower. You might do away with the server, away with the server, because you can trust the actors of the network to not to cheat on each other. So co-op games are a very typical use case of this, or chill games where there's no competition, like Animal Crossing. And in this case, the topology looks a little bit like this. So there's no server involved, but the clients are just speaking with each other. There's also an alternative to this version where you have this is usually called peer-to-peer or client-client or client-authoritative. An alternative to this is when you have one of the clients actually have special powers, and sometimes this is called client-host, because that client is hosting the match. So all the other clients have to connect to it. And this model, again, also works in trusted environments. And then the challenge here is also like you need to deal with what is usually called host migration. So what happens if the host disconnects? What happens to the other players? Do they get disconnected, or do they keep playing the game? And how do you move the logic of the game to the other players? So these are all decisions that one has to take, right? And there's the issue with players finding each other. When you organize the network topology like this, these players are on different networks in different parts of the world. They need to find each other. So there's this new concept that sometimes is introduced, which is called the relay server, that allows players to find each other and acts as a bridge between them. So there's so many topologies that you have to choose between. And again, for me, this was also very daunting. This is all stuff that I've learned in time. And I'm sure that like for many of you, when you set out to make your multiplayer game, you're always like circling these ideas back in your head. Sometimes they are dictated by the genre of game that you choose, and then you have no choice. Another way to see this thing is to look at authority or ownership. So every time you make a multiplayer game, you always have these entities in the game that make up the gameplay, and each one of them is usually simulated or controlled by one of the nodes in the network, be it a client or be it the server. So another way to look at this is authority. Again, who controls what, right? So in a shooter like, what is this called? Overwatch 2, the players don't actually control the state of their own characters, but they send inputs to the server, and then the server elaborates that, comes up with the final state, and sends back the final state to the players. So in this case, you can say that the authority is somehow split between the server and the client. In other games, client-host, usually one client, the one that acts as a host, has the logic, so it has authority on things, and then players send the input. And then sometimes you have models where like authority can be shared between clients. So I control my own character. I say where my character, and when I say I mean the client, right? I say where my character is, the other clients say where their character is, and then none of us has, let's say, authority on the other one, but we have shared authority on some part of the world. Again, this is a way to do things that only works when you know that the network is trusted, when the clients are not going to cheat against each other, which is the case for most co-op games like It Takes Two. Now, and this is where coherence comes into play, right? And I'm going to show you how we do things in this technology stack. Because I find the model that Coherence has very interesting. And when I was talking with them last October, to join the company, just hearing about this model was kicking game ideas in my mind. It got me excited because of how flexible things can be with this system. And that's why, actually, I think Coherence is a really great fit for game jams. Because then it really unlocks you from that strong and hard choice that you have to make in general. Do I use a server? Do I not use a server? Who has the authority on everything? And it speeds you up, I would say. So we actually sponsored the Global Game Jam back in January. I don't know if has any of you seen this, that we sponsored the jam? Okay, one person. That was worth it. 2 people, double worth it. It was money well spent. But we got a few games made. For a young company, let's say, that just revealed last November, it was a good result. We got around like 20 games made with Coherence during Global Game Jam, right? So during 48 hours. So with Coherence, the basic topology that we have is, I should really leave this water alone, is this. So we have clients, of course, and then we have a thing which we call a replication server. Now, replication server, and this is where terminology comes into play, though it's called a server, it really is more of a relay. Like the replication server just acts as a replicator, let's say, of states across clients. So every client has to connect to the replication server, and then they just send commands to each other or states when they have authority. In this case, for example, authority is completely on the client, so the clients do things on their own, they send them to the replication server, and the replication server shares them with the other client. We also support like many scalable network architectures, like in this case, and I have a demo later, maybe I'll show you, where you have a client with the Fox, you're running the Fox, so you have authority on your character, but then the simulation of other entities is actually spread around other network nodes, which are called simulators. So simulator is our concept of a server. When you talk about server controlled in Coherence, we're talking about this thing, the simulator. But at the core of it, there's always this replication server, which is our relay that connects all the nodes. So these 2 clients here are connected to the replication server, and so are the different simulators. And in this demo that I can show you later, the DEERs are actually run on the simulators, and they can move from simulator to simulator because this demo is about a big world. So this world is actually being handled by different simulators. And again, when we talk about authority, and that's the interesting part about Coherence, for us, authority is not something that you decide at the beginning, and you say, like, okay, my game is structured like the server decides and the clients obey. But the authority is actually a property on every network object. Again, network objects are characters, are physics items, or a thing that you can grab, anything that is interactable, that is interesting to the network. We use the prefab as a base, as a unit, let's say. And so every prefab can have authority here or there, and then that authority can be passed, can be moved around. And as you can see, this is the component that I'm going to show you later. And it has the authority here, simulate in, and then the option you get is client side, or server side with client input. But this is like just a starting point, and then you can pass that authority around during the match, which makes things interesting. For example, it frees you from that idea of like the host migration, like who's the host? Well, if the host falls, you can just take the authority of all of the entities that it was controlling and pass them to somebody else. And then the match keeps going without interruption, for instance, right? Or again, what I was talking about here, if one of the servers, the simulators, is at capacity and we have more DIRs to be run, we just run a new one in the cloud, and then we pass the authority of some of those DIRs to the new simulator that's now running. So it's a very interesting opportunity, I would say, that really flips things on their head and puts the power in your hand and allows for the creation of like different formulas, which I find very interesting. In Coherence, the authority is split in general. So every object can have two, let's say, components of the authority. One is the state and one is the input. When a client has both components, then we say that it has full authority. So for example, in a very simple demo, a character that you can move around and you just pass the information of the position to the server, in that case you have full authority. If you're just sending inputs to the server and the server is coming back to state, then we say that you have input authority and the server has state authority. But if you have both, you have full authority. And as you play the game, here you can see that the component is always showing like, what kind of authority do you have on this particular entity? And in this case, I have state, I have input, so I have full authority. So for example, again, in the simplest use case, a client and another client are connected, and this client has full authority over this character. You basically tap your keys, you process the movement of the character, and then the state, so the position and the rotation, you send it to the other client. That's it. The server has no play in this. And this means that you have full authority. In other cases, when you want the server to be in control, you have input and then the server has state, as I was saying before. Again, here the replication server is just acting as a bridge, and then we have the simulator which has the state of this character. And it means that this has the final word, right? So this is obviously the anti-cheat kind of network topology, where you want even if a player sends the wrong input because they have hacked the client, then the server will reply with the correct state. So the server always has the final word. We also have a case where like you don't have authority on something, and then of course, which is very common, like another character that gets spawned, you don't have any authority on it, and we call it remote. So that's represented when you say here like no, and then that's remote. Is it clear so far? I'm going very fast because I want to save some time a lot of time for the demo. So yeah, this, let's say, different way of seeing things, I think it's very interesting. And actually, I want to remark that when you look at this model, where the simulators are these, servers that run in the cloud, you should really, in the coherent sense, you should really think of them as clients that nobody is controlling. So you could think them as other players that are there, and you need to make the mental switch, because in some other models, normally when you architect things like a server and client, you are stuck there. But in this case, you should always think of the server as another client, and then you can move this authority to them or take it away. I'll show you there's APIs to request it, to steal it, and stuff like that. Okay. And then the other mental switch, and yesterday I was watching the talk by Esteban from Unity about Unity's netcode for game objects, and he talked about this as well. There's a lot of mental switch that you have to do when you start with multiplayer games, about understanding that as you make a normal game, you usually have a character and another character, and they do things to each other. But in a multiplayer game, you have these two characters here, and these two characters here, and these two characters here, and they're everywhere. And if you spawn one more entity, their entity, is also spawned in every other node. So you always have to think of the perspective of each node, right? And in this case, for example, from the perspective of this client, the character on the left, they have full state authority, but the one to the right is remote. But on the other client, the one to the left is remote, and the one to the right is full authoritative. So you always have to make this mental switch and prepare your code to deal and to always ask to the entity, do I have authority on you? And then do things accordingly, right? So every time you write some code, not all the time, but you need to make this mental switch of thinking that you might not have authority on that thing. So if you're bumping into an entity and you have something that triggers on collision enter, you might have to verify if the authority is currently here. Which again, for coherence is a big thing because the authority might have moved somewhere as a result of some gameplay action. Demo time. So let's do some demo because I can see you're like, this guy is talking too much. No? I can read minds. Okay, again, I went a bit fast, but now I'm going to show you everything in practice so you understand what I'm talking about. Can I do something magic? Can I put this to a lower resolution? No, it's okay. You can see things, right? Yeah. And if I zoom, it zooms. That's cool. Cool. Okay. So, all right, so now we're in Unity. I hope you're familiar with it. Are you Unity users? Yeah, okay. No Unreal because... Godot, I heard Godot. Jump animation, and then there's a land animation as well. So he has a fully running state machine. Other than that, he really is just a capsule collider with a rigid body. Usual stuff. This script here, move, is controlling the velocity of the rigid body, so it's just moving it around. So how do I network this thing with Coherence? Coherence comes as a package. So if I go to the package manager, this should be first set up in the, where is it? The package manager, you need to add a, what's it called? Scoped registry, which is this one. You can find this one on the Coherence documentation and do copy paste. Three, two, one. Come on, Unity. It's getting emotional. I don't know why. Usually it takes less. All right, and you get greeted with this splash window that shows you which version have you installed. 11, interesting. And once you're there, you can start working with the actual thing. So how do you network, let's say, a scene, and in particular, this character? If you go to this thing here, Coherence, we have this window called the Hub, Coherence Hub. It's a bit like a control center for Coherence. I like to dock it somewhere. And as you can see, it has a bunch of like sections, and each one has a certain function. But the scene one, for example, allows you to start setting up your scene. So there's 3 objects that we need to bring into the scene. One is called monobridge. If I click, it just gets created for me. The monobridge is, the classic thing, like I think in Photon is called network runner, network manager. It's like the object that will run the connection for you in this scene. So this one is actually going to allow us to connect. Then you need a thing called live query. Now, live query is a very Coherence thing, and it's basically a way to say, I only want to get network updates in this part of the world. So it's a game object, right? You give it a radius, as you can see here, and then it allows you to say which part of the world are you interested in. And this is necessary to have at least one, otherwise you get no updates whatsoever. But you can leave the radius to 0, which means infinite radius. And then the interesting thing is you can also actually have multiple of these. So you can have a live query here and one there. So that, for example, if you're using like binoculars, then you can move the live query to where you're looking at, and then you get updates about what you're seeing there. So you get updates here, right, on you, because you need to know when somebody hits you from the back or something, and from there. And you can really play with this thing to optimize how you handle big words. But we only need one. And the third item that we need, which is not mandatory, but it's good to have, is this sample UI. The sample UI is just a helper that we provide with the package to be able to just like click a button and join a server. Otherwise, you can always do it with your APIs, but with your coding, let's say. But the sample UI should handle all of the base cases. Once we have these three things, we can actually sort of connect, but we have nothing to send, so we should network this character. So the way we network the character, as I mentioned before, we operate on the base of prefabs. So the character is already a prefab, and then what I need to do, you see, again, here, everything was offline so far. I haven't added any network functionality. What I need to do is I go into edit mode, because I need to work on the prefab source, on the asset itself, and I add a component called Coherence sync. Adding the Coherence sync gives me this big chunky component with plenty of options. You remember we talked about the client-side thing, which I'm going to leave on client-side. Authority transfer, goodbye. Authority transfer is an option that allows us to select if this object can even be requested for authority or not. And if you disable it, which makes a lot of sense for a playable character, nobody will be able to take it from you. If you set it to steal, requests will succeed automatically. And if you set it to request, what the requester has to do is they have to wait for an answer. And then the object that has authority is able to answer and say like yes or no. This is a very typical use case, for example, when you have a vehicle and the vehicle is the object that somebody wants authority on because they want to drive it. And two players are approaching it, and then they need to request authority of the vehicle. One of them is going to fail, right? Depends on who arrives first over the network, who has the lowest ping. So one of them is going to get yes, and they get authority, and they start driving, and the other one is going to get no. And then they just stand there, and maybe the game shows like no, you can't drive. Okay, so this is made for giving you that ability. Not going to go over everything right now. What we need to do is we need to tell Coherence, let's say the system, that this prefab exists. So we can do it in different ways. We can, what am I doing? We can put it in resources. We can use addressables. Or we can use this thing that I like, which is called prefab mapper. So I just click this, and basically there's a scriptable object that has the list of all the prefabs that need to be networked. This is just a way for you to have prefabs that have a coherent sync in the project, but you're not actually using them right now. So here you will just list the ones that need to be included in the simulation. All right, so this guy is now enlisted, let's say. How do we decide what to network? We click on this configure button, again, on the coherent sync. And this configure button opens this hefty panel, let's say, called configuration. And configuration, as you can see, it scans all of the public properties of all of the components of this game object and allows you to network them. So just by checking, for example, you see position is already checked. Do you know why it's already checked? Does anybody know? Can you guess? Yeah, but yeah, I mean, they will always have a transform, that's for sure. But why do we always need to sync the position? Because since coherence is based on this scalability, and you saw the live query before, you remember that volume that allows you to ask for a certain things in a certain position, then we necessarily need to know where that thing is. So we want to network the position. Now, if objects are not moving, that doesn't mean that the position is being transferred all the time, because coherence is not stupid. It's not a human, but it's also not stupid. But it's going to transfer the position only once, right? But it is mandatory because we need to know where the object is in order to be able to transfer the state based on the live query that you have in the world. But here I want position and I want rotation. So I enable rotation, and you see here to the right I have this little control over the interpolation. So when the data is going to come back from the network, and the data doesn't come every frame, interpolation means that the data is not just applied and the object snaps to a new position, but it's going to smoothly transition and interpolate into the new position, right? So interpolation is a typical network thing that makes things a little bit more pleasing, especially when the lag becomes a bit higher. So it refers to the data that is incoming. So as I, with the state over this character, send the data, the other client will receive this data and it will interpolate it. And you can choose several models, so you can configure a new one by just creating a new thing, or you can code your own if you're crazy. No, I'm joking. If you're a pro. And then the other thing you have here is P. P means prediction. I don't think we need to go there now, but I can talk about it later. Anyway, you configure what you want to network, and as you can see, you can actually, you want to probably dock this window somewhere, which I like to put here next to the inspector, and then you can scroll into your game object and you can scroll the whole hierarchy, and you see that all of the properties can be networked just by going to the configuration. So all of the properties of this game object and its children can be networked through the single component that's on its root. So what do I need to network here? Position, rotation, and then what I want to do is I want to go into the graphics object. No, I'm lying. Into the player object, which has the animator, and I want to network actually the animator parameters. So all the animator parameters, just with a click, I can also decide to send them, again, only when they change. By doing that, the state machine is kind of working. The only extra thing I need, because you can network floats, bools, and ints, you cannot network like these triggers, because triggers are not necessarily, they're not like a variable in the state machine. So, so the way you would network triggers is you would expose, and here we go into the other part of the picture, a method. So here we have set trigger, for example, string. I'm saying to Coherence, I want to transform this thing into what is usually referred to as an RPC, a remote procedural call, I think it's called. So it means like a function that you can call from the other side of the network. So here I'm saying that this function needs to be ready to be called, and then I'm also going to tell it that I want it to be called to on everyone. And right now, if I were to press play, this character will kind of work. The only thing I need to call this function from my code. So the way I do it is I go back to the script that the player has. And this is kind of like the only real network modification that we're going to do to this script. So the thing we need to do here, we don't need to change the inheritance chain or anything like that. The only thing we need to really do is we want to get a reference to the coherence sync. I cannot type and talk. Sync like this. So I expose the public reference, which I can then feed into the into the inspector, and of course I'm only going to find the one on the root. And then when I need to call that trigger, which is somewhere, should have noted the line, jump. There we go. You see, where I'm calling the trigger normally on the animator, I can now also call it over the network, which is done by this, then this, and then this, animator.setTrigger. Second parameter is telling who am I sending it to. And then the third parameter is actually what I want to send, which is follows exactly the same signature as the regular method. So what I'm saying here from this script, which is the move script that the character has, is go to the coherence sync, which is the kind of like the brain of the networking, and invoke this command over the network to who? To others. So the authoritative one will invoke it to other entities over the network. What function do you want me to call? Is this one. So this is nice because it gives you like autocomplete. And then you pass this string along, right? Of course, this can be optimized. It can be an int. Come on, don't be boring. Like, this is just a quick demo. No, I'm joking, because it's a typical thing where it's like it's bad to call it with a string. Forget about it. So yeah, so the idea is that you're calling the same method on the authoritative one and on others. So here I'm calling it on myself, and here I'm sending it and propagating it over the network. And that's it. So now, if I go to Unity and I were to like try this game, actually let's try it. Let's go wild. Okay, I think I'm good. The thing you need to do then in order to try is to do what we call bake. So the reason why you can do without writing any netcode is because we generate the netcode for you. So as you configure these parameters in this configuration panel, and then you also map you expose the prefab, as I said, in this scriptable object, Coherence now knows that it needs to look at this prefab, and then it needs to look at those parameters, and then it can generate the code for you. So the way you do it, you can just go to the Coherence hub, baking tab, bake now. And actually, let me do assets. And when you do bake now, Coherence literally generates code and puts it into this folder here called baked. If you want to look inside, it's pretty complex. There's like all of the stuff that has been networked and all the Coherence needs to make it work over the network. You can totally modify the scripts, but I mean, it's how do you say? It's an endless tunnel. But now we're ready to go. And what I'm also doing, do you know of this extension, Parallel Sync? I heard a yes. So it's a very handy extension. It's open source package that you can find on GitHub. And what it allows you to do is allows you to have clones of this project. So now I have another clone here open, which is now sucking in like all of the, and obviously everything broke. Thank you so much, Parallel Sync. What is happening here? Let me try to reopen this scene. So the idea with Parallel Sync, and if it doesn't work, I'll make a build, but if it works, the idea is that it clones your project to another folder, and then it keeps them in sync. So as you work on the master one, every change you make will get copied to the other folder, and then you're able to press play on both editors and network them together. Yeah, something is doing, because I installed the package, okay. Okay, no, it recovered. Right, so now they should be in sync. So you see editor 1, editor 2, and then I need to launch, you remember, the relay, that thing that sits in the middle between two clients and that relays the state across the network. So to launch that, I can launch a local one just by executing this command, and the relay is now running on my machine. So I'm being both one client, another client, and the relay. Everything is running on this hardware, right? And then I can press play. If I press play, I did words, so I need to, oh no, let's launch the rooms one actually. It's more common. So local server rooms. And then here I press play. And then here you see it says local region. And I can create a room, Ciro's room, no, NGJ, create and join. So now I'm connected. All right, so my player is now technically connected. Who has authority on this player? Me. because I'm the one who instantiated it, right? So if I go to the Coherence sink, you can see that I have both state and input. You remember those two components. And then if I go to the other editor and I press play, I see the room has been created. I can join, and I get the other character. But now something is going to happen. I think I already know what's going to happen. If I move, oh no, it's going fine. Why? And it's happening here. Why is it not happening here? I know it is happening here. Okay. So what is happening here? Sorry, this is the most unscripted demo ever. I'm controlling this guy, which I have authority on. But what's happening is I'm also controlling this one. You remember when I said, you always need to think in your code, do I have authority on this entity? And you could do it with a series of ifs, and if Coherence Sync has authority, blah, blah, blah. However, there's a quicker way to do this, because what is producing the movement on this character, and you see what's happening here, like I'm moving this one just fine. Also the animation is like porting fine. This one, what is he doing? He's trying to move, but then he gets reset to the position. Because since I don't have authority on the left one, it means that that state is being sent by the other client. So I force it to be something different, but then the other client overwrites it every time. So Coherence detects that the movement has changed, and then it resets it to the position that the client with authority is telling me. So anyway, how do I fix this thing? It's very simple. We go into the original Unity editor, select the player, and we look into the third tab of the Coherence configuration panel, components. If I open the prefab, again, I need to open let's go into prefab mode. Components. Components basically allows us to do things based on whether you have authority or not to the different components. In this case, I want to disable the input. I want to disable the script that produces the movement and tweaks the animation. And I want to make sure that the rigid body is set as kinematic. So now, when I lose authority over this entity, these two scripts are going to be disabled automatically, and the rigid body is going to become kinematic, which means that there's not going to be any physics run on this character, but I will trust the state that comes from the other client. And I can see that it's already, and I do this. Now you join, and then I go in here. I hope that Parallel Sync has done its job. And you can see that now they don't clash anymore. Because if I select one of these characters, and look, the two players have been instantiated. I mean, this one I instantiated it here, so I have full state authority. And this one has been instantiated by Coherence as part of what we call network instantiation. So it came to my scene because it was on the network. And this one is showing me that I have no authority on it. And for this reason, this one has these components disabled, and the rigid body is currently set as kinematic. So anyway, this was a very quick crash course of the basics, I would say, of Coherence. So you know how you configure prefabs, how you configure methods, and how you basically dress up the scene to get started. There's obviously much more to it, but this, in a way, is kind of like, it can allow you to make a multiplayer game in sort of like 10 minutes. And an interesting thing is it's also very easy to remove. So one thing that I would suggest, you can try. If you, by, let's say, Saturday afternoon, decide that it's not good and you just want to keep the game local co-op, for example, you can easily strip out most of the, the functionality and just revert it to local. There's also one type of what's it called? Authority state, let's say, which is the orphan, and that's because an entity usually gets created and dies with the user that makes them. But we also have a concept of persistence, so you can actually leave an entity on the replication server, even if you disconnect. But that entity right now, nobody has authority on, so it's an orphan. When you get back online, you can get authority on it And there's actually a parameter on the coherence sync, I don't know if you noticed, which is called auto adopt. Where is it? It's here. Auto adopt orphan. So you can set entities also to be auto adopted. So you can really play with this authority, move it around. You can make an entity persistent. You create it. Like, for example, I don't know, I've had the magic of spawning water bottles. I create one, and the player disconnects. The next player that reconnects will find the water bottle where it was, and he can request authority on it and stuff like that. So there's a lot of flexibility and interesting things that you can come up with. And I think persistence is one of the funniest thing to play around with. Cool. I think I'm mostly done. I want to leave some time to breathe and to maybe for the next speaker to set up. What is this? Yes. This is a demo that I prepared, but I think we have no time to play, and also I don't think anyone has a computer right now. I know some people do. Well, if you want, you can just jump into this demo, and I can play while I talk, maybe. This demo is a tutorial that you can download, and you can explore it. So you can look at the Unity project, how it's built, and don't try from the phone. Sorry, I have a phone version, but this one is not going to show controls on the phone. What was I going to say? Every scene details one aspect of coherence. So there's basics of synchronization. The second one is physics and transferring authority. The third one is parenting entities to each other, moving platforms, and so forth. And the last one is persistence, which is actually quite interesting. So it looks like this, just for your own curiosity. Is anybody playing the demo? Let's see. Because through Coherence, you can also publish to WebGL. And then you can, let's see if somebody's there. And then you can share it on Coherence's cloud. There we go. Hello. Let me be a good citizen. Hello. No, it bugged. Okay, let's go to another scene. Can you come to the physics scene 1 second, please, whoever you are? So the physics scene is interesting, and the way I configured it is all the crates are basically physically simulated, right? And as I came into this scene first, these are simulated on my machine, so I can push them around. But Mr. Web User here, and Web User 2 and me, well, that's bugging, but forget about it. What are they doing? As soon as they touch the crates or they grab the crates, you can see that they got authority on them. I colored objects to show authority. So for example, this crate, I can grab it, and now it's mine, and it's moving physically for me. So I can spin it around and throw it. This one, the orange one, is currently a kinematic rigid body. You can see that it doesn't react to the throw of my crate because it's still simulated on some of your phones or computers. Yeah, some things are bugging around, but it's not Coherence, it's my code. But you get the point. You can really play around with making authority not something that is set in stone, but it's passed around. And this way you can sort of distribute a physics simulation. Don't get me wrong, this doesn't mean that this is a deterministic physics system that is good for a competitive game, but it might be good for this game jam. Yeah, something is really bugging around. And last thing, very last thing, and then I'll go off, is the persistence. So this scene here shows these flowers that you can plant. Somebody plant them, and thank God they didn't draw a swastika or any kind of weird thing. So these are left from a previous session. It's always risky when I come into this scene. And then you can plant new ones, right? And as cool person, sure. And as I as I disconnect, you can see that the objects have, sorry, I'm making a lot of jokes. The objects have been cleared, but then as I connect again, and please, I hope you haven't drawn, Jesus. You can see how the persistent object that cool person and his friends or her friends have planted are persisting on the server. and I can also clear them, clearing them. You can also see how somebody cleared them for me. Thank you. But you can also see how the authority of them is on your computers. When I clear them, to clear them, you will notice that they will briefly go blue because I'm requesting authority on them, and then I can destroy them. So there's always this game of like moving authority around, which I find it pretty fascinating. And with this, I'm gonna close the demo. You can keep having fun in your worlds. I wanna leave you with the one final meme. And now you can finally understand it, why Batman is such a flexible entity. Because he can be authoritative, remote, but he's also an orphan. Sorry. Anyway, this is me. I hope I made you curious. I didn't put any single, action link to click on. I'm sorry. But if you Google Coherence game, you will find the website, you will find the docs, and then you can download the package and try it out. There's obviously a free plan, so you can just try it out for the jam. If you're curious, and I will be on here all weekend. So if you need help, then I will be able to help you with technical things. Thank you so much.